Hello, MA 120 students. I just love working with you. You are a fantastic class, and I appreciate all your active engagement. So last week, we spent some time getting to know each other, and we started the midpoint and distance formulas. But in Tina fashion, I got a little sidetracked, and we decided to take an excursion to Salt Lake City and calculate some distances, and it took a little bit too much time, so we didn't actually get to talk about the generation of the distance formula. As a result, I'd like to take one moment, generate that distance formula, and actually apply it to two problems for you. That way you have a reference point moving forward to do your homework. Though I did notice a lot of you have already started it. Great job so far. So let's talk, where is the origination of the distance formula? Well, it comes from what we discussed in class, which is right triangles and the Pythagorean formula. Let me begin by taking 2 points in space, and we'll label them with coordinates, x and y, because we're on a plane. And to designate the difference between these 2 points, we'll assign them different subscripts. So my first point, I'm going to label x1, y1, and the second point, I'm going to label x sub 2, y sub 2. Ooh, that doesn't look very nice, does it? Let's just label that better, x sub 2, y sub 2. So these are my 2 points in space, or specifically on a plane. If I want the distance between these 2 points, I want the distance as the crow flies, which is the distance straight across to them, which we talked about as being the hypotenuse of a right triangle if we drop down and make both a vertical and x distance, or component that corresponds to that distance. So distance is the straight distance between the 2 points. I'll call that d. And then we have horizontal and vertical components. In the right triangle, we can look at this and label this horizontal side as side A and the vertical side as side B. So the legs of our right triangle are A and B, and our hypotenuse has a measurement C. And that corresponds directly to what we know as the Pythagorean formula, which says that for any right triangle, the 2 legs, A and B, satisfy the equation such that a squared plus b squared equals c squared, where c is the hypotenuse. So now we're all caught up, and now let's relate this into x's and y's, so we can create our actual distance formula, which you guys have seen in a previous class. So we're just regenerating some old knowledge, but it's always good to bring it forward. So what is A? A is a horizontal movement, or in other words, it's an x movement or x distance. It's the distance between the 2 x coordinates. How do we get that? Well, we take one value minus the other value. We talked about that on a number line. To get the distance between them, we subtract the values, and we take an absolute value to represent distance. In a similar fashion, B, which represents my y distance or my vertical movement, well, that's a vertical number line, and if I want to get the value between those y coordinates, or those y values, I would take y2 minus y1, or y1 minus y2, take an absolute value. So now we're ready to create that distance formula. We're all set. Here we go. So what is A? A is my x distance, which is the absolute value of x2 minus x1. So I'm going to write down A and convert it into the absolute value of x2 minus x1 all squared. But I'm going to stop real fast here. We've got absolute value squared and a lot of symbols. I can actually get rid of those absolute value symbols. And why is that? Why can I remove those absolute value symbols? Well, we need them to begin with because distance is positive. But if I'm going to square something, it doesn't matter whether the value inside is positive or negative. I could have a positive 5 or a negative 5. When I square it, I get the same thing, a positive 25. And so really, in reality, having the absolute value is unnecessary when I'm squaring that quantity. So I'm going to remove it to make it a little simpler for the i's. In a similar fashion, I'm going to convert b, and I'm going to change b into terms of y values. B is just y2 minus y1 squared. Excuse me, b squared is just y2 minus y1 squared. And that's going to equal c, but c is just my distance, or d squared. And so we have generated that distance formula that you guys have seen at some point in your career in mathematics. D squared, if I take a square root of both sides, will give me d. And so d is just the square root of x2 minus x1 squared plus y2 minus y1 squared. That is the distance between 2 points in an xy plane, x1, y1, and x2, y2. Let me show you nice and neat. Here we go, the distance formula. The distance between 2 points, x1, y1, and x2, y2, is the square root of x2 minus x1 squared plus y2 minus y1 squared. This you'll want to commit to memory, take a snapshot, put it in your notes. You use this not only in this course, but you'll use it in Calculus 1, you'll use it in Calculus 2, and if we add the z components, which is plus z2 minus z1 squared, you use it in Calculus 3. So you will use it in your entire math career. All right, so let's go ahead and use this formula and apply it to a problem. Suppose we have the 2 points, 3, 2, and 11, 8, and I want to find the distance between those 2 points on a plane. I don't care how you do it, whether you drop and make a right triangle and use Pythagorean formula, or simply use the distance formula. And I think I'll just practice using the distance formula. But again, however you do it, as long as you get the right answer, I'm all good with that. So, let me take and label my points. I'll call this one x1, y1. I'll call the second point x2, y2. Doesn't matter which one you call which. That's the beauty of this formula. It works either way. We are calculating this distance between them. And so we are going to subtract the x coordinates. x2 being 11 minus x1 being 3. Square those values. The y coordinates, square those values. Put it all together. 11 minus 3 squared is 8 squared. 8 minus 2 is 6 squared. And I want to put a little note and stop and pause. A lot of people are tempted right now to square root this 8 squared, but you can't. The order of operations tells us we must simplify whatever is inside a square root as far as possible first. So simplify first as far as possible whatever's under a square root. And doing so, I'm running out of room here. That's going to give me that the distance is the square root of 64 plus 36. And I think we might have did this one actually in class at the end of class. That was the square root of 100 or simply 10 units. So I think I'm redoing one that we did in class, but that's okay. I think in class we actually used Pythagorean formula to calculate it. So here is the distance formula giving us the same answer. And we'll finish this real fast video with one more example for your notes. This one's going to have some negative numbers in it. Purposefully did that. So let's determine the distance between the points -4, 1 and 5, -2. I actually don't need to visually plot them. I myself love visualizing things because it helps to give me a better idea where everything is. So if possible, I like to plot them. I'm going to call that first point -4, 1, and I'm going to call him x1, y1. And that second point which is 5, negative 2, I'm going to be labeling x sub 2, y sub 2. And I think I did not label this guy here, negative 4, 1. All right. And I'm going to, again, use my distance. I want to use my distance formula as an example. Although, again, you could use Pythagorean formula. If you happen to like right triangles, you go for it. But if you like formulas, I'm going to calculate the distance between the two. Let me write that formula down again. The more often I pull it back from the recesses of my brain, the greater likelihood that I'll remember it in the future. So I'm going to pull that up as x2 minus x1 squared plus y2 minus y1 squared. I'm going to subtract my x coordinates, x2 being 5 minus x1 being negative 4, y2 being negative 2 minus y1 being 1. So we should be getting negative 2 minus 1 squared. And we'll be a little extra careful here just to go through this. A negative, right? 5 minus negative 4 is actually a positive. So that's as if I was taking 5 plus 4, right? So 5 plus 4, and 5 plus 4 is just 9. So I've got 9 squared in that parentheses. Additionally, and here's an example where we're actually getting this negative number that we're going to square inside. Negative 2 subtract 1 is actually negative 3. So I'm going to be squaring the value of negative 3. But that's okay. Everything is beautiful. Remember, I said before you do anything, you want to simplify whatever is inside your square roots, and this is something that you want to do whether you have numbers or letters or anything. Calc 1, Calc 2, Calc 3. Simplify what's inside first. 9 squared is 81. Negative 3 squared is 9. 81 plus 9 is 90. So it seems to me that distance is the square root of 90, which, if you're not allowed to use a calculator in class, you could just leave it as the square root of 90. If you are allowed to simplify it, let's just do a little bit of simplification with a radical as practice. I could think of 90 as 9 times 10, and the reason I would do that is 9 is a perfect square, right? The square root of 9 is 3, and so I could also think of that distance as 3 times the square root of 10. If I wanted to get an approximation, I would pull out my calculator, and we would discover that the distance is approximately, hang on, pulling out my calculator, type in 3 times the square root of 10, I'm getting 9.486832981. So just under 9.5 units. Alrighty, so that's the distance formula. Generated from the Pythagorean formula. We've done 2 examples. I think you guys are going to be just awesome doing your homework. If you have any questions at all, don't hesitate to email me, and I'll see you all in class this week.